Welcome to the Algebra 2 video for skill number 88. I can add, subtract, multiply, and divide functions, and write and evaluate composite functions. We'll start our notes on page 88A, and we have been doing this all year long, and this is just formalizing it. What we're doing is we're doing operations with functions. So if you wanted to take rule F and add rule G, and it would be notated this way, it's just add one to the other. Similarly, if we're subtracting, we just subtract one from the other. Multiplying, we multiply one function times the other function, and division, we divide one function by the other function. I'll show in examples below what this means. So if we're given, and this is how it'll appear generally, we'll be given a list of equations. And the first thing they ask us is to find g plus h of x. So we take our g of x, and we write g of x, and then we want to add h of x. And h of x is this one, so we add the absolute value of x minus 1, and then we combine all of our like terms. There's only one absolute value symbol, the 2x is by itself, and then negative 5 plus negative 1 is negative 6. Or perhaps we want to do f times g of x. So f of x is this one, so we write f of x times our g of x, which was the second one, times g of x. And we will use the distribution method of x squared times 2x is 2x to the third. X squared times negative 5 is negative 5x squared. 3 times 2x is positive 6x, and 3 times negative 5 is negative 15. And if we had any like terms, we would combine them. The process continues on down with g minus f. So we take our g value, which is 2x minus 5, and we subtract our f value, which is x squared plus 3. So we subtract x squared plus 3. And after writing it into standard form, we find that that subtracts out to being that. And finally, the only one which is slightly different is f divided by g. So when we do this, what we have to do is write our f rule divided by our g rule, and then we list any constraints that this sort of function operation creates. And since g is 2x minus 5, we find that x can't be 5 halves. On the next page, 88b, we learn about composition of functions. And this says f of g. That should be a circle. It looks kind of like a dot, but it is a circle, a small circle. It kind of looks like the word fog. F of g of x is when you take g of x and you plug it in for the variable for the rule f. So use the value of g of x as the input into f. And we see that down here. We're given 3 possible functions, and we're asked to find f of g of 4. So that means what we're going to do is plug g in to f. So g is root x plus 5, and they want it for 4, so we do root 4 plus 5, which is basically equal to f of root 9, which is f of 3, and then we stick 3 into the function of 3 minus 3, and we get 0. The second one, h of f of 5, means h of f of 5. We stick 5 into our f rule, 5 minus 3, so we have h of 5 minus 3, in other words, h of 2, and then we stick 2 into our h rule. And our H rule says x squared, so we go 2 squared, and we get 4. And the next one, we do g of f of 10. I'm going to shrink this just a bit. All right. G of f of negative 10. So our f is negative 10 minus 3, x minus 3. Negative 10 minus 3 is negative 13, so we want to find g of negative 13, which is root negative 13 plus 5, which is root negative 8, which is not a real answer, but if we wanted to calculate out the imaginary answer, we find that it is equal to 2I root 2. And in the final example, what we have is h of g of x. So h is the rule that we plug g into. So we take the rule g, root x plus 5, and plug it into h. So we take root x plus 5 as our variable. So we square that. Now the interesting thing here is we find out that the answer is x plus 5, but we had a constraint because we're not allowed to take the square root of a negative number. So we had this x plus 5 is greater than or equal to 0, which means x is greater than or equal to negative 5. So we have an answer with a constraint on that answer. All right, the key ideas and concepts for this are the fact that we should be able to take some rule, for example, f of x is x plus 7, and g of x is x squared. And if I asked you to find f of g of x, what that means is we plug g of x in for our variable, so f of x squared, which gives us x squared plus 7. If I wanted the other direction, g of f of x, then that is going to be g of x plus 7, which is x plus 7 quantity squared. We should also be able to add, subtract, multiply, and divide these functions. So if I asked you what is f of x minus g of x, you would say that that is equal to x plus 7 minus x squared, which if we wrote into standard form would be negative x squared plus x plus 7. All right, we should get the subtraction in there. I won't show addition, multiplication, and division, but those are also ideas we need to be able to consider and do. Thank you.